Alright, looking at chapter 2.4 today, doing a quick self-check, which would put you in a either good position or bad position for this. If you can answer yes to all three of these questions, then today should be an easy day. If you can't answer yes to all these questions, and the only reason today is going to be tough is because of a fundamental thing, because in all honesty, it's really an easy section to add on. If you understand first how to do one-step equations with work, showing plus 5 divided by whatever and all that stuff. If you understand how to take that a step further and do two-step equations with work, and after you have that down, if you have a decent grasp on whenever you have to combine like terms or use a distributive property, then today, being technically your last lesson in solving for a while, everything else just gives you a process to use that leads to a fundamental solving problem. So be sure to work hard today and you'll be in great shape for the chapter test. You do have a quiz coming up on this because I need to make sure you know how to do what you're supposed to do. If you're still having issues solving, then you're in for a long chapter. So again, make sure you use the days coming up to ask whatever questions you can, because solving issues right now mean you're going to have a big problem when everything starts kind of combining together. The essential question is, where does this fit in with everything you've already learned? Pretty much the material we're going to learn today is just below our rule of simplify first. This is still going to be your number one, or still should be your number one strategy no matter what, is to simplify the left side completely, simplify the right side completely. That has nothing to do with solving. Simplify first just means that you want to make sure everything's in simplest form, and then once both sides are simplified, what you're going to do is check to see if you need to deal with variables on both sides. In order to solve an equation with the variable must clearly declare one side. So if you look at this problem here, 2x plus 3 equals 7x minus 6. Let's say we want to get this x alone, so we send the 3 over here. Well, the problem is we send it over here, but there's a 7x over here, so we send everything over to this side. Well, if we send it over here, now there's a 2x that doesn't want anybody there, so you send it over there, and you pretty much send numbers back and forth, because you have two people who want to be alone on each side. And if there's only two sides, and the person who wants to be alone is on both sides, then nobody else really has anywhere else to go. So again, if you remember that the variable wants to be alone, you cannot do it if both sides have a variable. So we fix the issue by moving the smaller variable to the other side. For example, in this case, 2x is smaller than 7x, so we would actually start out by sending 2x over here, which we'll talk about, and then we solve the problem as usual. And the way we move the 2x is by using its opposite. For example, this is a positive 2x, so we would use a negative 2x, and that is it. And that's pretty much the notes you need. Again, everything else is going to come down to whether or not you practice like you're supposed to and ask questions where you need to. I think it's a very straightforward chapter. I think it's a very straightforward section. Just, again, make sure you stay up to speed on everything. In this question, 3x plus 17 equals 5x plus 9. Our number one rule, our left side is simplified because you have an x and a number, can't be simplified. X and a number can't be simplified, but we do have an x on the left and an x on the right. And all we're going to do is move this 3x by simply subtracting 3x from both sides. And if you remember combining like terms, 17 comes down, 5x minus 3x is 2x, and then plus 9. And now you notice we are home. We have a two-step equation where the first thing we move is the 9 by subtracting it. 17 minus 9 is 8. That equals 2x. Then we divide by 2, getting 4 equals x. That's it. So as I said, just make sure you understand. Number one rule still is to make sure everything is simplified. After that, if there's a variable on both sides, move the smaller one over to the bigger one, and everything is just easy from there. Looking at this one, 10x plus 21 equals 2x minus 3. Again, this is simplified because everything is just a variable and a number. Here is just a variable, also in a constant, I guess I should say. So what we're going to do is say 10x and 2x. I'm going to move the 2x, again, by subtracting it because it's positive. 10x minus 2x is 8x plus 21 equals, that goes away, and be careful that you bring down a negative 3. From there, x is here. We want to move the 21 first for those of you who have practiced like you're supposed to. 8x comes down with negative 24. You then divide by 8, and x is equal to negative 3. I want you to think about the new stuff that I've done so far in this lesson, and the only thing I've done new is moving the smaller variable to the larger variable. Everything else, again, stays the same. That's why I said this is a pretty straightforward lesson. You've just got to make sure you've got that checklist taken care of, because if you haven't mastered one-step, two-step, and multi-step equations that look kind of like this, then you're in for a long day. Here, again, the first rule is simplified. This isn't simplified, so what I'm going to do is distribute my 7, making this 7x minus 35. This side is also not simplified, so I'm going to distribute my 6, making it 6x plus 30. Left side is simplified as far as it can be. Right side simplified as far as it can be, but we have variables on both sides, so we simply move the smaller variable to the larger variable. 7x minus 6x is 1x, but you do not need to write the 1. Don't ever write the 1 because it kind of confuses things. Minus 35 equals, that's gone, 30. Then you add 35 to both sides, getting x equals 65. Okay? And then the last one on this portion, again, this side is not simplified, so we're going to distribute. We get 2a minus 12 equals, on this side we have to distribute a negative, so we have 4a minus 2a minus 12. This side is not simplified, so we're going to rewrite our 2a minus 12. Over here, 4a minus 2a is 2a minus 12. What happens now is we have variables on both sides, so notice what happens when I go to subtract 2a. 2a minus 2a is gone. 2a minus 2a is gone. The only thing left is a negative 12 on this side and a negative 12 on this side. Now this leads you to one of two options. It's either no solution or it's infinite solutions. And the way you tell the difference is whether this is true. If this is a true statement, that means that it is a solution, which means you would say infinite solutions, which is our answer. But if you were to get an answer like 3 equals 6 or 4 equals 11, that's false. Those would be no solution, and that's what you need to look out for. So again, I needed to show you one in case you see it, because it is going to be on your homework. But other than that, like I said, just make sure you're aware of what's going on with that when you see it. Take good notes on that. We are also going to start seeing inequalities, which is the less than, greater than symbol in our work. Follow these rules when this occurs. Notice I didn't even make you write it. I just want you to understand these three rules. First off, the variable in the inequality must be on the left side. Second, the symbol flips when sides are changed. Third, the symbol flips when you're switching signs. In terms of inequalities, what we're looking at is we've ended problems with 1 equal to x. Because if you look at what happens when I flip this over, what does the equal sign do? It still looks like an equal sign. So it's the same thing. But notice what happens when it was 1 is greater than x. Again, that's a greater than symbol. If you flip that over the right way, notice that it now says x is less than 1, which means you actually converted the sign. And so whenever you do this, you want to make sure your variable's on this side, because when we start graphing these things, that symbol, when variables on the left, tells us everything we need to know. So again, that's what we're looking at in terms of our preparation. But outside of that, the symbol doesn't really do anything unless we're moving the x to the other side or switching signs, which we'll talk about. Here, in this case, x is on the right. Everything is simplified. We're going to add 14 to both sides. Negative 20 plus 14 is negative 6. Notice I didn't do anything to change my x, so the sign just stays the same. And then x comes down. The only thing is I cannot start, as rule number 1 says, I cannot stop with the variable on the right side. So what I have to do is bring my x over, bring my negative 6 over, and flip the sign. That is what we have to do on that question. Okay? On this question here, 16 minus x is greater than 29. You got to make sure again that you solve first the same way you normally would, which is this is 16, we're going to move it, it's positive, so we subtract 16. But what comes down is a negative x is greater than 13. Again, the sign doesn't do anything because I haven't either switched sides or signs. But if you remember, what I taught you is anytime you have a negative x, you want to make it positive. And because that 13 is positive, you want to make it negative. But again, in this case, when I'm switching signs, this is the other time when the symbol switches. Alright? So it switches when your x is on the wrong side, and it switches when there is a negative sign attached. Looking at this one, you have negative x over 9 is less than 5. Notice there is a negative sign attached to x, so the first thing I'm going to do is switch my signs the way I've taught you. 5 becomes negative, but this switches, and then we solve as usual. We multiply both sides by 9. X comes down because I wasn't changing anything. The symbol stays the same, giving us negative 45. Same thing here. Negative 16x. We have a negative attached to x, so what I'm going to do is change my 16 to be positive, switch my sign around, turn this to be 288. Then I divide by 16. I don't know what that is. I'm thinking 8, something like that. 18 and then an 8. So x is less than 18. But again, because that x was negative, you switched it around, everything made like it needed to be. And then the last one before we get ready to wrap it up is we have to move our 18 by adding it. Again, we did not mess with the x, we did not move our x, so everything stays the same. Negative 5x comes down, the sign does not move, and I think that is 100. But now you notice that there's a negative attached to x. What we're going to do is switch my 5 to make it positive, turn the sign because that's what I'm supposed to do, make my 100 negative, and then divide by 5, which again does not affect the symbol, and it gives me negative 20. Alright. So now that you've seen every fundamental skill necessary, focus on applying the necessary strategy. Again, remember, it is take care of simplifying first, then make sure your variables are on one side, which means declare a side, and then everything else to take care of itself. Again, in the end, solving is simple. It's just sometimes it takes 1 or 2 steps, maybe even 3, to set yourself up to where you can actually get into solving. And just remember that simplifying, turning this into this, is not solving. That is simplifying. So the solving comes in when I start moving to 1 and doing all that stuff. But distributing, combining like terms, that's not solving. That's just simplifying, which again isn't even part of solving, but it's thrown in there just to kind of make the problems that you're going to be seeing in this chapter and get you ready for them. So other than that, like I said, make sure you use the time wisely, get as much stuff as you can done, and good luck.